So here we have a cylinder initially rotating with angular velocity omega 0, and it was placed on inclined plane as shown in this figure. Inclination angle is alpha. So we should find time when it will reach its maximum height. So initially it was just rotating. So its center velocity equal to 0. It is not moving. It is only rotating around its own axis. So basically velocity in this direction initially equal to 0. It's only rotating. So what will happen when you place it on inclined plane? Initial velocity equal to 0. First of all, in order to understand what kind of motion or in which direction it will move, first of all, we should draw all forces acting on this rotating cylinder. Basically, free body diagram. So let's start with, it has a gravitational force, weight, reaction force, perpendicular to the surface, and of course we have a friction force between rotating cylinder and the inclined plane. Without this friction force, it cannot move. It is moving upward, it means we have a friction force. What about the direction of the friction force? Since this point of the cylinder moving or rotating in this direction, friction force is directed in this direction. Let's call it just F1. F1. No any other forces. So it will move upward in this direction because we have a friction force. Downward we have a mg sine alpha. So basically we can write Newton's second law. Upward we have a friction force. Downward we have a mg sine alpha. That's why it will accelerate upward. So this is the direction of the acceleration. Let's call it A1. Since we have a slipping at this point, since we have a slipping here, basically sliding, friction force already reached its maximum value because we have a slipping between cylinder and inclined plane. It means friction force equal to coefficient of friction times normal force, because we have a slipping process there. We know that normal force equal to mg cosine alpha in this case. Let me substitute, let me take F1 friction force into the first equation, first formula. Then we will have this kind of equation, mu mg cosine alpha minus mg sine alpha equal to m a1. We can cancel masses. So basically it will accelerate upward with this acceleration, mu g cosine alpha minus g sine alpha. With this acceleration it will move upward by slipping, by sliding. And after some time, this sliding, slipping process will stop. Somewhere here, for example. It will move upward without slipping, without sliding. Basically, it means velocity of the cylinder at this point will be equal to 0 because no slipping, no sliding anymore. And let's say its angular velocity at this moment becomes omega 1, for example. So initial angular speed equal to omega 0. At the moment when slipping process ends, angular speed becomes omega 1, for example. And it will be moving in this direction with certain velocity v1. Now, initially it was rotating clockwise, and anti-clockwise we have a torque of the friction force. That's why angular speed decreases with certain angular acceleration. Let me call this angular acceleration alpha. So final angular speed equal to initial angular speed minus alpha times time. Because angular speed decreases with angular acceleration alpha. Basically, this is a T1. T1 is the time till the sliding process ends. So this is a T1. This time equal to T1. T1 is the time when it slides, basically. And we know that we have a torque of the friction force. Weight cannot create torque. Normal force cannot create torque because they are passing through its center. Only friction force can create torque in anti-clockwise directions. That's why angular speed of the cylinder decreases. So let me write the torque. F friction force times radius. This is a radius. That's why it has a angular acceleration. And we know that friction force equal to this one, mu mg cosine alpha times radius equal to moment of inertia times angular acceleration. This is a cylinder, so moment of inertia equal to mr square over 2 times alpha. So mass, we lose it. One of the radius we can cancel. So mu g cosine alpha equal to r over 2 alpha. From here to mu g cosine alpha equal to r times alpha. So we have this kind of relationship. Maybe it will be useful in future. This is a acceleration. So someone noted that I am using same physical quantity, same symbol for angle of inclination, and as a angular acceleration. So let me change it quickly. So let's use different symbol for angular acceleration. So let me use epsilon E. In this case, we cannot confuse angle and the angular acceleration. Okay, now let me consider our cylinder as a dot object. Initial velocity equal to 0, final velocity v1, its acceleration equal to a1. So we can say that v1 equal to v0 plus a1 t1. Why plus? Because it's accelerating upward. Initial velocity equal to 0 at the beginning. So v1 equal to a1 t1. And be careful, or you should be, we can say that at this stage, we know that slipping ends, velocity of this point of the cylinder becomes 0. It means v1 equal to omega 1 times r, because we don't have any sliding slipping process. So v1 also equal to omega 1 r. So we can say omega 1 r equal to a1 t1. So let me take omega 1 from this equation and let me bring it into this equation. So omega 0 minus, this is angular acceleration, which is epsilon, times t1. This is omega 1 times radius equal to a1 t1. So let me open this bracket, parenthesis. So we have as omega 0 r minus epsilon r t1 equal to a1 t1. This part equal to 2 mu g cosine alpha. So omega 0 r equal to minus 2 mu g cosine alpha times t1 equal to a1 t1. So in this equation, we have only one unknown, t1. A1 is here, So we can find time when slipping sliding process ends. So let's continue. Omega 0 r equal to a1 plus 2 mu g cosine alpha times t1. From here, t1 equal to omega 0 r a1 plus 2 mu g cosine alpha. So let me, so here a1, mu g cosine minus g sine. Let me use it here immediately. t1 equal to, so here mu g cosine, 2 mu g cosine, so it will be 3 mu g cosine alpha minus g sine alpha. So basically this is the time when sliding process ends. Further, it will rotate, it will move without slipping, without sliding. Now, this is a T1. After this time, we have a rotating cylinder, but without sliding, slipping process. So it's still moving upward, but without slipping, without sliding. And it will reach its maximum height, for example, somewhere here. It means its velocity here in this direction, let's call it V2, this becomes 0. We should find after how many seconds its velocity will become 0. So again, we should draw free body diagram. Here we have a mg. Further, we have also friction force, but it will be different friction force because no slipping. And this friction force, let me call it F2. It is not equal to this one because no slipping, no sliding. We have a friction force, but it is not equal to mu mg cosine alpha anymore because it's not sliding. And again, we have a normal force. So basically, let me draw it here again. Upward, we have a friction force 2. In this direction, we have a mg sine alpha, and it will stop somewhere here. It will stop somewhere here. Why? Because we have an acceleration in this direction. Let's call it A2. That's why its velocity becomes 0 after some time. So here initial velocity V1, here final velocity equal to 0. So this is the direction of the acceleration. Or we can say deceleration. Now let me write again Newton's second law for this process. We are 100% sure that acceleration will be directed downward. So we can write mg sine alpha minus friction force equal to ma2. Mg sine alpha is greater than friction force. That's why acceleration will be directed downward. That's why it will stop its motion upward after some time. Basically deceleration. Now we know that it was rotating at the beginning of this process with acceleration with angular velocity omega 1, and we have a angular acceleration. Let's call it E2. It's different, likely. We have a friction force F2, and the value for friction force unknown. That's why let me write torque, because friction force creates torque. F2 times radius equal to moment of inertia of the cylinder times angular acceleration 2. Because after slipping, after sliding process, it will move, it will rotate with different angular acceleration, and let me call it E2. Friction force times radius equal to moment of inertia of the cylinder equal to mr square over 2 times epsilon 2, angular acceleration 2. And we know that this process is motion of cylinder without slipping, without sliding. It means angular acceleration equal to acceleration over radius, it means. Because no slipping process we have. So here we can continue mr square over 2 times angular acceleration, which is acceleration over radius. So from here, friction force 2 equal to ma over 2. Now we know what is a friction force. So now we can bring it into first equation and find acceleration. Let's see, mg sine alpha minus ma2 over 2 equal to ma2. Basically, mg sine alpha equal to 3 over 2 ma2. From here, acceleration equal to 2 over 3 g sine alpha. Basically, this cylinder will decelerate with this acceleration. So initial velocity v1, final velocity 0 due to this a2 acceleration. So we can write that final velocity v2 equal to initial velocity minus a2 t2. Why minus? Because of deceleration. Yes? And the final velocity, of course, becomes 0. At this point, it will reach its maximum height. So we can say that v1 equal to a2 t2, and a2 is given here. And what is the v1? v1 is the initial velocity for not slipping process, but at the same time it's the final velocity for slipping process, sliding motion, which is actually equal to a1 t1, as you see here. v1 equal to a1 t1. So v1 at the same time equal to a1 t1, which is a2 t2. From here, t2 equal to a1 t1 over a2. So total time of motion will be equal to t1 plus t2. So let's see what we will have. t1 plus t2, which is a1 over a2 times t1. Let me take t1 out of the parenthesis. So here we will have 1 plus a1 over a2. a2 is given here. a1 is also equal to this one. Let's see what we will get at the end. I will continue. Total time equal to t1, and t1 also we already calculated, equal to this one, omega 0 r over 3 mu g cosine alpha minus g sine alpha. This is a t1. Let me check again. Yes, this is a t1. This part equal to t1 times, here we have 1 plus a1 over a2. What is a1? a1 equal to mu g cosine minus g sine. Mu g cosine minus g sine alpha. This is a1. Divide by a2. 2 over 3 g sine alpha. Basically, let me take 3 here. 2 will be here. Now, further is totally mass. We should be very careful. Total time equal to omega 0 r. Here we have a 3 mu g cosine alpha minus g sine alpha. Times, here we have a 2 g sine alpha. Here 2 g sine alpha plus 3 mu g cosine alpha minus 3g sine alpha. So as you noticed, here we have a 2g sine alpha minus 3g sine alpha. Here we will have negative g sine alpha. So basically 3 mu g cosine alpha, this part, which is equal to this one. So final answer will be equal to total time W0 omega 0 r. Here we have a 2g sine alpha. So this will be final answer. After this time, it will reach its maximum height.